Okay, let's dive into this. Welcome to today's explainer. Have you ever actually stopped to think about what happens the exact millisecond you tap a link on your phone or maybe make a call from your car? We are literally surrounded by this incredible invisible infrastructure, but very few of us actually know how it works under the hood. So today, we're going to uncover the magic of modern telecommunications. We'll be looking directly at how field technicians and engineers visualize the journey of your data.
Here's our roadmap for today. We'll start with the pulse of the network. Then we'll trace fiber to the home, track mobile data on the move, see exactly why voice gets VIP treatment, and finally, we'll cover the golden rule of telecom.
Section 1. The pulse of the network. Visualizing data. Let's get right into it.
So in the telecom world, a service flow is essentially the complete journey your data takes. You got to stop thinking about the network as just static pieces of hardware, cables and metal boxes. Instead, it's a living stream of traffic. Now, what's really interesting about this is how the service flow bridges three distinct segments. It starts with the access segment. That's the first mile connecting your specific device. Then it hits the backhaul segment, which is kind of like the middle mile or a highway that aggregates all the neighborhood's traffic. And finally, it reaches the core segment. That's the centralized brain routing your data out to the global internet. If any single one of these segments fails, the whole flow just stops cold.
And this brings us to a huge pitfall known in the industry as the technician's trap. Think about the difference between a physical and a logical connection. You might have a perfectly fine physical connection. Cables are snapped in and hey, the status lights are glowing a happy green. But that absolutely does not guarantee you have an internet connection. Why? Because the service flow is logical. It requires a software handshake. It needs proper configurations and active authentication. If that logical flow is broken in the software somewhere, you can plug and unplug those cables all day long, but that green light, it's just lying to you.
Section 2. Fiber to the home. FTTH Internet.
We can actually trace fiber to the home just like a drop of water moving through a pipe. Step 1 is your home router, or ONT. If the light there is red, the physical fiber itself is broken. Step 2 is distribution at the local exchange. This is where the network checks if your subscription is actually paid up and active. Step 3 is the backhaul, where thousands of users' data are merged together onto a massive, high-speed highway. Step 4 is absolutely crucial, the core network. Think of this equipment, called the BRAS, as passport control. It grants you a public IP address. Without this passport, you might be connected to the network, but you are not allowed to step out and see the global internet. And finally, step 5, you reach your destination.
So how do technicians actually fix this when it breaks? Well, they use an essential pro tip. The ping is your best friend. Instead of just blindly guessing, a tech performs an end-to-end ping test. First, they ping your home router. If that fails, the local fiber is bad. Simple enough. Next, they ping that passport control we talked about, the BRAS. If that fails, the neighborhood highway is down. Finally, they ping an external server, like Google. And if that fails, the core internet routing is broken. It's just a brilliant, logical way to isolate exactly which segment of the service flow is blocked. No guesswork required.
Section 3. Mobile data on the move. Dynamic connections.
Let's move to the mobile site and see how this builds because things get a lot more dynamic. Step 1 here is the air interface, those invisible radio waves connecting your phone to a tower antenna. Step 2 is the baseband unit inside the tower. This thing schedules your data, literally telling your phone exactly when it's allowed to transmit. Step 3 is the backhaul, shooting that data back via microwave or a fiber pipe. Step 4 is the mobile core, which is constantly authenticating your SIM card and tracking exactly which tower you're connected to right now. And step 5 is the internet. Because you are physically moving, the network has to constantly adapt. It is exactly like passing a baton in a high-speed relay race.
Let's quickly contrast the two. With a fixed flow, like your home fiber, the connection is physical and it's stationary. If it breaks, it's usually physical fiber damage, meaning a technician has to literally go splice a cable. But with a mobile flow, the connection is a logical radio link. It is incredibly dynamic, requiring constant handovers between cell towers as you move. So the bottlenecks here aren't usually broken cables, they're things like radio interference and network congestion.
Which leads us to this really fascinating troubleshooting trick, the handover test. If a user complains about intermittent mobile data drops, the very first question a technician will ask is, does it happen everywhere or only when you're driving? If the service only drops when you're moving around, the physical tower itself is usually fine. The issue is a botched baton pass. It points directly to a neighbor cell configuration error, where Tower A simply forgot or failed to hand you off to Tower B.
Section 4. Voice service. The VIP treatment.
Nowadays, voice calls aren't just simple analog lines, they're voice over IP, and this brilliantly illustrates why voice requires entirely different handling.
Data service has pretty low sensitivity. If a YouTube data packet is delayed by 200 milliseconds, it just buffers slightly. You probably won't even notice. But voice service, that requires real-time delivery. If a voice packet is delayed by that exact same 200 milliseconds, your conversation instantly becomes unintelligible. So to solve this, networks use quality of service, or QoS. They assign voice traffic a VIP tag. If a network router starts getting congested, it will purposefully drop your YouTube packets just to leave an empty, clear VIP lane for a phone call.
As the saying in the industry goes, voice quality is about consistency, not just speed. This introduces what we call the jitter test. Jitter is basically the variation in the time it takes for packets to arrive. If packets are arriving at wildly different speeds, the caller's voice starts sounding metallic and, robotic. So if a site has terrible voice quality, simply throwing more bandwidth at it won't fix a thing. The technician actually has to stabilize the link to eliminate that jitter.
Section 5. The Golden Rule, Site Documentation.
Look, all of this incredible high-tech magic completely falls apart without basic human accountability. The absolute golden rule for field technicians is to document everything, before and after their work. In the before phase, they have to take wide photos, log the exact status of the gear, and verify the condition of the cabling so they aren't blamed for existing spaghetti wire messes left by the last guy. In the after phase, they must take a photo from the exact same angle, log every single serial number replaced, and verify the green lights. This is the ultimate bridge between the physical site and the remote network operations center.
This strict discipline protects the network for sure, but it also protects the technician. So the crucial point is avoiding a second kind of technician's trap. Let's say a tech leaves a site and it suddenly fails 3 days later. The network operations center will absolutely blame the last person on site. Without properly labeled after photos uploaded securely to the cloud, the technician has zero evidence to defend themselves. Keeping photos on a personal phone that can get lost or broken is just a recipe for disaster. Documentation isn't just annoying paperwork, it is the ultimate proof of a healthy service flow.
Well, we've covered a lot of ground today, haven't we? From the logical streams of your home fiber, to the high-speed baton passes of mobile towers, all the way to those VIP lanes reserved just for your voice. So, I'll leave you with this thought. Next time your internet dips or a call suddenly drops, are you just going to look for a blinking green light on a plastic box? Or will you actually visualize the invisible, perfectly orchestrated service flow working constantly all around you? Thank you so much for joining this explainer, and keep questioning how our amazing world connects.